This is the ESP-32 microcontroller, and it's quite brilliant. It's a dual-core 32-bit microcontroller processor with a whopping 320k of onboard RAM. I think these things are absolutely brilliant. Now this is a solderless breadboard. You may have seen them here on the channel before. And these things are also absolutely brilliant. The simple plug and play features of being able to connect pins to quickly prototype whatever it is you're trying to build. So both things are actually brilliant. There is, however, one slight problem, which is if you try and use an ESP-32 on a typical size breadboard like this, yes, it'll fit, but ESP-32s are generally so wide that you can't actually connect much either side. You can only ever have one spare row either side, and that is incredibly annoying. Yes, I know that these breadboards technically can actually break apart and unclip on the edges, and you can build bigger boards by clipping parts together. But in my experience, because you have to take the underlying self-adhesive pad off, all the metal pins start falling out the breadboards and they're never quite the same again. However, all that is about to change thanks to this fantastic development kit brought to us by Motoduino. So, introducing the NodeMCU ESP-32S development kit brought to us today by Taiwanese-based manufacturer Motoduino Lab, who specialise in IoT solutions. Motoduino Lab is just one of the many tech-based suppliers on the rather brilliant techdesign.com IoT marketplace. TechDesign's unique marketplace allows a direct source and link between manufacturers and people like us in the hobby tech community, bringing together over 500 plus verified electronic design and manufacturing suppliers to support you throughout your product development journey. You can also jumpstart your project by leveraging one of TechDesign's 1,600 plus customizable electronic hardware and IoT solutions to not only reduce cost, but also reduce time during your hardware development. So whether you're sourcing a small quantity of components for testing or a larger purchase for mass production, all orders are processed and shipped directly by the manufacturers listed on techdesign.com. Okay, so let's take a closer look here at the Motoduino Lab NodeMCU 32S IO board development kit. And first impressions, really good. I have to say, I really like how these things are actually packaged now in these really hard plastic shells. That's been kind of common with a few products now, and I actually really do like it. So let's take a look inside and have a look. And there's quite a few things here in the standard kit. So first of all, let's just bring out the main board. Here we are. So this is the main IO development board, and it looks really nice. We'll come back to that in a moment. We've got a sensor of some description here. I think this is a temperature and humidity sensor, if I'm right. We've got USB to micro USB cable, and we've got two packages which we'll come to in a moment. We've also got this, which looks a little bit like a telephone cable. It isn't. It's actually a RJ11 cable. I'll come back to that in a moment. And yeah, we've got two more mystery packages here. Now, I'll be completely honest with you. When I first agreed to review this kit, I honestly thought it was just going to contain the development board here, and you'd have to supply your own ESP-32. What I didn't realise is they actually include a brand new ESP-32 in the kit, which I think is absolutely fantastic. So let's just see if we can open that. And there we are, really nice. So here we are, this is a brand new ESP-32. ESP-32s, by the way, are dual-core 32-bit RISC CPU chipsets, and they have approximately 320k of RAM, which by dev board standards is huge. And these things are very capable. And let's take it off its protective foam. And you can see here underneath, it's by NodeMCU. And this is a NodeMCU 32 version 1.3. That's really nice. That is the board that's going to power our development board. Let's just have a look what's in here. Again, another little bag. Might just need to grab a pair of scissors for this. Okay, what's in here? Ah, you can see that. It's a tiny little OLED display. It's really nice. It's got a protective film top. And if I just show you here, you can see it's got 4 pins. So that's ground voltage, SDA and SCL, which are standard serial pins. So yeah, we'll get back to looking at that in a moment. So we take a closer look here at the main board itself. This is an iMoto ESP-32 I/O board. And what's really nice about this is it's actually pre-soldered together. Let's have a look at the other side. So it's a simple 2-sided PCB, but really, really nicely done, professionally made, really high quality. And what's nice is it's actually together. So I actually ordered a kit from a completely different manufacturer, a completely different kit for something else a little while ago. And I was a bit annoyed when it just showed up with a blank PCB and all these bits in a bag, and I had to solder it all together, which means I'm spending time soldering dev boards together. I'm not actually developing anything. No problem with this at all. So it's got lots of other great features on board. So we've actually got the ability for a 12 volt in barrel jack. We've got a voltage or power regulator, so we can go from 12 volts down to the required 5 volts. I think we can actually go lower than that, down to 3.3 if necessary. We've also got jumpers, so we can select between 3.3 or 5 volts. On this side, and I've never actually seen this on a dev board, so I really like this. We've actually got the RJ11 plugs, and these are broken out for various functions, so you can actually clip and cable in to various pins straight on the ESP-32. And we're going to use that in a moment, but let me just show you what those are. So, and they are labelled here on the silk screen. So I'm just going to tilt that to the camera so you can see. So it's digital, analog, UART, and I2C. So basically these are the serial links, and it's actually here, if I can show you that on the silk screen. So it's all really clearly labelled out. By the way, this thing I think it's got a little buzzer on as well. So this board's actually got quite a few great functions already on it, and we have various buttons. So for the GPIO pins that are not broken out over here, they're all listed here in a long line on the GPIO header. This is quite unique. It actually has ground in black for each individual pin. It has red, which is the positive, which you can switch between 5 volts or 3.3 volts, and then you have the individual pin itself, and that's a really great feature. And of course that's the great feature that you can mod and edit this board depending on what you need to do, and you can tap straight into the solder joints underneath, which is going to be ideal, especially if you want to include this product in a further design. You want to embed it in a project that you're doing. So that's really, really cool. So let's just take a quick look here at the temperature and humidity sensors. So I'm assuming this is the panel here, and it's a little breakout board, again 2-sided, nice little plastic housing it's in. And it has one of the RJ11 plugs right here. So we can connect this in straight away. We clip one side, and we can clip straight into the board the other. And that will be connected like so. But of course none of that's going to work unless we actually put in the ESP-32. Now, a great feature about this board is you'll notice how it's got a double stack of connectors. So a single line of female connector pins one side, and then there's double stack. And that's because it's actually designed for a multitude of different ESP-32 boards. Although most of them look the same, some of them are a little bit wider than others, like I showed you in the introduction. So if I took, for example, my original board here, which is a little bit wide, and by the way, I need to make sure we get it the right way around. So ESP-32s all have onboard Wi-Fi, by the way, and the antenna is always up here, and there's the USB plug on this side. If I wanted to plug this in, I'm just going to do that now. My board, let's just bring that up so you can see. My board actually needs the additional pins because it's just 1 pin wider than most. You can see there how mine fits. However, we don't need to use that because we've got this superb unit which is supplied in the kit itself. And this one's a little bit narrower. It's a bit longer, but a bit narrower. This will fit really nicely. There we go. First time, no problem, straight in. And you can see how that fits in on this board. So yeah, I really, really like how this works. Now the OLED display has its own dedicated space that it fits. So if I can show you just above the aerial here on the main ESP board, you can see there's 4 pins or 4 female pin sockets there. Fits really neatly in like that, and you can see there's the pins labelled to ground, VCC, and the 2 serial lines SDA and SCL. Okay, so you've seen what's in the NodeMCU ESP-32S development board kit. But how about setting it up and actually doing something? Well, this is where the NodeMCU ESP-32S really comes into its own. The PDF download document was really simple and clearly laid out, and things, well, just worked. It's really cool. Let me show you. Alright, so let's take a look at how to actually upload code to this version of the ESP32, which is obviously the main board that powers this dev board itself. Now for this, I'm going to use a Raspberry Pi 400, which is a Linux-based machine, although this will work perfectly fine on Windows PC, but you will need the CH340, I think it is, 340 or 320 driver, which you can find very easy online. If you run a Linux system, be it Pi-based like this is, so ARM, or if you run x86 or x64 PC for Linux, you don't actually need the drivers, so this will just work. So what we'll do first of all, we're going to grab our micro USB to USB-A standard cable and see we light up. Now I'm using 64-bit version of Raspbian Linux, and I've pre-installed the Arduino IDE. By the way, this comes with a really good instruction manual. It's clear, it's colourful, it's clear, it works really well, and it talks about first of all installing the Arduino IDE, which is kind of crucial for this to work. So I've already done that. Let's open up Arduino IDE. And it just opens with whatever I had open last. Let's just go, we'll open an example. So Blink is a good example, some example code. This is stock to Arduino IDE. Now we need to install the boards. I've already done it here. So the board drivers is under preferences, and there's boards manager here, and what you would do is you would add this line here. It's actually all in the PDF manual, and you just add that line, which I've already done. Click OK, OK again, then under tools, boards, and it would be board manager, and we'd do a search for ESP32. If you haven't got the drivers installed, here it is, ESP32 by Expressive Systems. This is what you need to install. I've already got the driver installed, so that's fine. Then it's just a case of under tools, with boards, ESP32, and the particular model which this system uses, we scroll down, here it's the Node32S, which we select. That's this particular brand of ESP32. And I have to make sure we're on the correct port, which in this case is dev TTY USB 0, which is selected. And we can click to get board info, and if that comes back with something, we know we're talking to the board, and that's fine. Okay, so this is the Blink, which is one of the very simple examples. It's under Examples, Basics, and Blink. This is just a raw C-based Arduino code, mainly designed for Arduino microcontrollers, but this should upload fine to the ESP32. So let's click to upload. It'll then compile the sketch. There we go, we're just uploading now. It's writing the data. There it is in hex to the memory. Job done. And you can see, here we are, we're flashing. That piece of code works fine, which actually means the system works fine, and it truly is as simple as that to get this up and running. So turning our attention back to the instruction PDFs, and I want to introduce you to a IDE environment called Moto Blocky, which is actually an online environment that's best used through the Google Chrome browser. Well, here on Raspbian on the Pi, we're actually running in Chromium, which is the sort of open source Google version of Chrome. And I can just click this link here. And this is going to take us through to Motoduino's Lab Inc. website. You may notice the majority of it is in Chinese, but don't worry about that. Just click here. And this is going to open up a fantastic little IDE space. Now, again, it's all in Chinese. Again, not to worry. We just click here and we click English. And we can then select the board, which is ESP-32, right at the end here. Basically, this works. If you've ever used Scratch from MIT, it's exactly the same concept. And you can actually bring in all kinds of logic and clip pieces and actually build programs. So I've got a repeat loop, for example. I've got repeat, having clip inside, repeat 10 times, do, etc. We've got color settings, random color. So we can actually write programs without needing to know how to write C, effectively, which is the main programming language that the Arduino IDE uses. Okay, so I've been given an example which we can actually upload. So if I go to upload, there we go, and we'll say open. There we are. So this is actually a file that I've just loaded up, was off effectively my C drive on the Pi, or the hard drive space. And this is a program for using the sensor and the OLED screen that came with the kit. And you can see it's really pictorial. So there is the kit, the actual device. It's actually sort of shows you in pictures. And we can set parameters. So here's some hex we can set up. Change resolution, clear. Set where the cursor is. So it's really, really good. It's quite simple. You can see how the program works. Now, if we're on Windows, we can download a tool that allows the web-based environment here, Moto Blocky, to actually upload directly through the browser to the ESP32. However, it only works on Windows. If you're not running on Windows, and I'm just running within browser here, so it's not platform specific, we can do an alternative. But first of all, we need to download Arduino libraries. So while that's doing that, I just want to show you this tab here, which is ESP32. If we click that, it actually gives you the raw C source code. And this is completely compatible with the Arduino IDE. We can click the green paperclip here, which will copy the code. And if we happen to have a blank sketch open in Arduino IDE, we can actually paste the code straight in. There it is, and that's ready to go. Or we can actually download the file as an Arduino sketch. And we knew that, so I'll just call it whatever and let that download. And you see it's downloading as a .ino Arduino sketch file. So let's go and find where that's downloaded. There it is. Cut. And let's pop that into here. And if I double click, that should open up in the Arduino IDE. And it will say it wants to go into a folder. So we say, yes, that's fine. Go into a folder. No problem at all. And there we are. Now, this won't compile straight away because it's looking for certain libraries that we haven't actually got. So that's why we were downloading our library. So we need to add these libraries. And if we go sketch, include library, add zip library. And we go to downloads. And we can click. We can keep it in the zip file. We can open that. And that'll take a moment. That should install the new libraries into the IDE. Right, so we've now installed the libraries. So, moment of truth, let's see if we can upload this code. Now, bearing in mind at the moment, we've got the flashing blink test program happening on our board. So let's do the upload and see with the libraries installed. Hopefully this will work and we should see something come up on the OLED type display. So the code has been uploaded successfully. Now you can see we've actually now got some temperature information on the screen. The temperature and humidity sensor is actually plugged in via RJ11 port straight into the ESP32. I really like that function about this board. And as you can see, it's measuring here on the screen temperature and humidity. Now, as part of the sketch, I actually added my local Wi-Fi details. Remember, the ESP32 has onboard Wi-Fi, and I registered an account on something called ThingSpeak, which is an online data IoT service. And I set up 2 channels here. So this is the Wi-Fi shoot demo. and you can actually see the two fields it's measuring, it's actually sending out to this remote server and feeding back to me. So you can see here on this screen, we've got temperature, which has actually been steadily climbing. This is just the room temperature it's measuring. We're now at 24.5 degrees, and that's because obviously we've got studio lights on and this thing's been heating up a little bit. Humidity has actually been dropped. So we were at 77 and we've dropped down a little bit. And that's actually just been collecting that data since I started running that at about 10 past 11 this morning, and we're just running for about 30 minutes or so, 20-30 minutes, and that's actually collected that data remotely, which is actually really, really interesting. So we can see how we can actually set up a really simple Internet of Things type setup. If I have this, for example, let's say outside in a weather station box, or I don't know, let's say a greenhouse, as long as I can get an internet connection, now those things would probably be near enough to my local Wi-Fi that I would be able to pick up remotely outside. I could actually receive local data straight back live, and I can actually watch what is going on. So that's just, you know, a really cool demo feature, if you like, of this actual kit. So there we are, the NodeMCU ESP-32S development board kit by Motoduino Lab, and brought to us today courtesy of techdesign.com. I also found on the NodeMCU ESP-32S product page at techdesign.com the full pinout for the dev board. So again, documentation for this is really clear and thought out. If you're interested in ESP32 microcontroller development, the NodeMCU ESP32S development board kit by Motoduino Lab is a fantastic place to start. Again, all product links are in the video description. And if you do want to see more product reviews from myself here on Wi-Fi Sheep, then do check out our review and unboxing playlist. And remember to like and subscribe if you haven't done so already, and I will see you real soon right here on the channel. Until next time, bye for now.